Welcome to OSDU Data Platform Application Developer Training, DDMS Core Concepts module. In the prior modules, we have already talked about the generic APIs to discover and access data in the OSDU Data Platform. In this presentation, we are going to introduce the second option, which is called Domain Data Management Service, or DDMS. These are the services of the platform that provide the optimized, type-safe, and domain-specific access to the data in the platform. They carry semantics not possible in a generic APIs, making them a powerful tool for application developers who want the very best performance and scalability for accessing data. Let's take a look at the diagram. We have a number of core services that are not domain-specific. They provide generic APIs to use them. They could be used with any data in any business domain. They have no real knowledge around any business rules or what is data, how it is used, or understanding how data is consumed. DDMS APIs, on the other hand, extend the platform generic functionality and deliver capabilities that address domain-specific consumption patterns. For example, the Seismic DMS has API to access seismic trace data in OpenVDS form, while generic normal APIs may only access this data in the SIG-Y form. Another example, the Wellbore DMS can provide API to access specific log mnemonics or data frames, while the generic APIs may only be able to deliver the original LAS file into an application. Let's take a look at the main OSDU data principles. The idea of this slide is that any service, including DDMSs, should not violate those principles and play nicely with the rest of the services because they are all integrated into one platform. For example, if the data was ingested using DDMS service, it should also be discoverable with the generic search service, so that the metadata is shared between DDMS and generic services. At the same time, sometimes DDMSs will require certain exceptions because they often extend the standard data model and operate at a more granular level, since they carry some knowledge about the data they work with. For example, a DDMS may introduce the deep search capabilities such as finding and fetching data frame of the well log in a specific range of depths. Because the generic search service does not typically index the well log content, its data is only discoverable using DDMS but not the generic services. However, in general, any DDMS should be based on a standard data model, standard entitlements model, as well as appreciate all other data principles mentioned in this slide, with some occasional exceptions. DDMS services are part of the OSDU data platform. They are governed by the forum, developed as part of the common code, packaged and distributed in each OSDU data platform release. In other words, they are not external add-ons to the platform. Unlike applications which are developed by vendors, DDMSs must follow the architecture principles and process governed by the OSDU forum. In addition, each DDMS corresponds to the single vertical discipline such as seismic or petrophysics, or a functional aspect of multiple disciplines such as the Earth model. That means that there should not be two or more different implementations of, let's say, seismic DMS, so that the applications that are being developed for the discipline workflows can rely on the same platform behavior. If there is a need to introduce additional functionality to a DDMS, it should be incorporated into the existing service rather than a new service is created. Finally, DDMSs are designed to support the variety of workflows, many of which are already implemented in existing applications and solutions which may vary from one organization to another. Therefore, the DDMS APIs are highly opinionated, may require transformation of data into the specific format, or even provide overlapping functionality. For example, OpenVDS and OpenZGY libraries. As an application developer, you should explore the DDMS's capabilities and choose the approach that works best for you, as sometimes there will be multiple ways to implement a work. It's important to understand that DDMS API can be implemented in several ways. It can be a service exposing web API, maybe based on HTTP or gRPC, or even using different protocol. It can also be a library, for instance, C++ library, that you can embed into your application for an optimized data access. It can be a CSP technology exposed directly to SPI, Service Provider Interface, that can be included in your applications and services as Java or Python packages. In the complex cases, such as handling seismic workflows, it can be a combination of those three ways working with domain data. With regard to designing your applications and choosing between the generic APIs and DDMS APIs, we typically recommend using the generic APIs to do the operations like import, export, and basic search. So if you are working on a tool to transfer data from an existing system to OSDU data platform, or maybe building a catalog of your data, then looking at the generic ingestion and search services will be your first choice. On the other hand, if you need to interactively read portions of data such as web logs, visualize and filter data frames, run the ML algorithm, and write the results back to OSDU, then using DDMS is likely a much better option. Many applications will use a combination of generic services to discover data and the corresponding DDMS to access the content. What you want to avoid is fetching source data into your application, parsing and saving it there into one of the supported OSDU formats, running the algorithms on a subset of extracted data, and saving the results to a local application storage. This is the anti-pattern because you duplicate the functionality of OSDU in your app, making it more expensive and potentially less efficient. And on top of that, you lock the improved and derived data inside your application instead of sharing it in the platform, which is one of the main reasons OSDU data platform was created in the first place. There is a list of some examples of DDMS services which can be highlighted. It's easy to group oil and gas subdomains like seismic, petrophysics, and others because almost every big organization and operator will have these domains. So the goal is to unify the approach in APIs for each of these domains. This diagram might look a little bit overwhelming because it is designed to convey multiple messages with regards to the platform architecture. First of all, DDMSs rely on the core services to register datasets in the catalog. That's the light green line connecting all the DMSs with the OSDU data catalog, and also the dark blue line connecting them with the special content storage services. Second, each DDMS can use one or more special storage service, such as a document database and a blob storage, depending on the needs. Those are dotted yellow and purple lines. These special storage services hide the underlying technology and minimize the number of them in the platform. So for example, from the operations perspective, we only have one blob storage service, one relational service, one document database, and one time series database to manage. None of that matters for the application developer though, because applications don't interact with the underlying technologies or even core services directly. This is the final and most important message of this slide. Applications should utilize a combination of generic APIs and DDMS APIs to discover and access data in the platform. As part of Mercury release, two DDMS APIs have been already delivered. These are Wellbore DMS and Seismic DMS APIs. We will take a closer look at how to work with them in the next videos. It is worth mentioning that even though those APIs are generally available, they are being improved to better integrate with the OSDU standard data model, and this is still work in progress. If you build your application against M7 or newer release, you may already see a different version of these services or an updated behavior of these APIs. The other two APIs, Well Delivery DMS and Reservoir DMS, are still being worked and should become available later this year. Thank you.